So, today we are doing the same thing as yesterday, except we're doing the graphing in radians. Before we do our first problem, there are a couple conversions you have to be aware of, and these are ones you're going to want to have memorized. 30 degrees is equal to pi over 6 radians. 45 degrees is pi over 4. And 60 degrees is pi over 3. I find these kind of easy to memorize because pi over 4, 45, they both have a 4 in it. And then the pi over 6, if you were trying to make a pattern, would match with 60 degrees, but it doesn't. It matches with the opposite, which is 30 degrees. And then pi over 3, its opposite is 60 degrees. So these are the main three you have to have memorized outside of pi being 180. That's the main one. If you can remember that, half pi, pi over 2 is 90. That's preferred, but that one's not required. All right, let's do our first example. First, let's set up our blanks. Theta equals, alpha equals, and we have our trig functions. The main three going down, we have sine, cosine, and tangent. And the reciprocals, cosecant, secant, and cotangent. For example 1, theta is 5 pi over 4. And that's given, so let's go ahead and answer that theta is 5 pi over 4. Reminder, you may not convert this to degrees and then do the whole problem in degrees. If we give you radians, your answers must also be in radians.
Are you ever going to change this order up so mess with?
So that's actually a good question. I had this switched, but on the quiz/test, theta and alpha will be at the bottom instead of the top. Otherwise, these 6 will always be in this order. So I hope that doesn't mess things up too much. I could have sworn they were at the top, so that's why I started doing that. Yes?
Could we switch it to degrees as like a check for our answer?
That'd be fine. Just all your graphing and your answers here must all be in radians. Yeah. All right, graphing. We know that the right side is 0. Left side is pi. And if we make this a fraction, this is out of fourths. So this is 4/4 pi. Over here we have 0/4. And then if we go all the way around, this is 0/2 pi, so 0/4/8/4 pi. And we're graphing 5/4. Clearly we're going to go past the first 2 quadrants because we're going to have to go past 4/4. Is 5/4 in the 3rd or 4th quadrant? Yep. So we're going to land in here. So let's draw in the angle of rotation. Again, theta is 5 pi over 4. Next, we find alpha. Alpha, x-axis, to where our angle ends, to the terminal side. What is it?
One more time?
Yes. So the whole thing here is 5/4. If we subtract 4/4, we have 1/4 left. So 5 pi over 4 minus 4 pi over 4. Alpha, you can write 1/4 pi or just pi over 4. Reminder, the alpha must also be in radians. When we're working inside of the triangle, we're about to draw, that's when we're going to switch it over to degrees, because triangles, their angles are always in degrees. Let's create our triangle. We go from arrow to x-axis. Giron, could you close the door, please? I don't know what's going on out there. Thank you. So from here on out, we'll focus on the degrees now. So again, hopefully you're working on memorizing the conversions. Pi over 4 means that this angle inside of here is 45 degrees. And I don't really have a good place to put it, so I'm going to actually put it outside the triangle.
How would you know it's 45 degrees instead of 36 degrees? Like I can tell like on this one, other ones, how would you?
It comes from alpha. Alpha's pi over 4, which is 45 degrees.
Okay.
So, as you can see, we have a 45, 45, 90 triangle. (45, 45, 90 are the angles. What are the sides of the triangle? Yes?
1 radian, curvature.
Yes. 1 rad 2 square root 2, however you want to say it. So, the legs across from the 45s, those both have length 1, and the hypotenuse is square root 2. Remember, there's an extra detail you need to be aware of here. What is it?
Double negative.
Yes. We're on the left side of the x-axis where the negatives are, so that's a -1. And we're going under the x-axis, again, where the negative numbers are on the y-axis. So both of these ones are going to be negative. Reminder, square root 2 is always positive because of Pythagorean theorem. If I found this via Pythagorean theorem, using our -1s, we'll still get a positive answer. Lastly, we have to label HOA. H, hypotenuse, is across from the 90. O is always on the vertical side, opposite the adjacent, or sorry, the alpha. And then A is on the vertical, or sorry, the horizontal, my goodness. A is on the x-axis. Let's set these up. Sine O over H. That's -1 over the square root of 2. Reminder, we cannot have the square root of 2 on the bottom of a fraction, so let's fix that. Times square root of 2 over square root of 2. That's negative square root of 2 over just 2. Cosecant, we take the reciprocal, and let's do it of the original so we don't have to do all this work again. That's going to give us negative square root 2. Cosine is A over H. And we're going to get the same thing. -1 over the square root of 2. So I know my result is going to be negative square root of 2 over 2. And secant and cosecant are going to be exactly the same as well. Tangent, O over A. That's -1 over -1, which is just 1. And if we flip that cotangent, it's still going to be 1. Questions on example 1? We're going to do one more of those. Example 2. Let's just set up our blanks, please.
So if you're 45, 45, 90, will you always have two answers that are the same?
I'm trying to think. If I'm thinking correctly, it's only in quadrants 1 and 3 that happens, but I could be wrong on that. It's been a minute since I've had to think about it that hard, but I'm pretty sure quadrants 1 and 3, yes. For this problem, theta is 7 pi over 3. Let's graph. We have 0 on the right, pi on the left, and then if we make a full circle, it's also 2 pi at the starting point. Putting this in thirds, this is 0 thirds, or 6 thirds pi. And then over here, this is 3 thirds pi. Where is 7 pi over 3 going to land us? Jack? It is. So as you can see, a full circle around gets us 6 pi, but we're not there yet. We need 7 pi over 3. So we're going to go 1/3 further. That will land us in the first quadrant. So our angle of rotation is going to look a little interesting. Start here. We're going to go around 1 full time and then some. And our theta is 7 pi over 3. Alpha, x-axis, up to where our angle ends. And you want to take a shot at that.
1/3 pi.
It is 1/3 pi. So we go around a full circle plus an extra bit. So that full circle is 6 pi over 3. So the calculation behind it is 7 pi over 3 minus 6 pi over 3 is 1 pi over 3. Or if you prefer, just pi over 3. So alpha is pi over 3. Don't change it to degrees yet. Get it in the answer blank first. Now let's create a triangle. We'll go arrow to x-axis. So this time we're going down to meet it, creating that right angle. Now that alpha, we want it to be in terms of degrees. When we talk about triangles, our angles are always in degrees. So this is pi over 3 radians, which is 60 degrees. We wrote those conversions above. That's why you want to have those memorized quickly. So 60 degrees, and again, I don't really have a nice way of writing it, but this angle inside here, that's a 60-degree angle. And the 30-degree angle is up top. As you can see, we have a 30, 60, 90 triangle. What are the side lengths associated with that? That's correct. 1, radical 3, 2. Yes, you must have those memorized. So across from the 30, we have a 1. Across from the 60, we have a rad 3. And the 2 goes on the hypotenuse. Are any of those sides negative? No. We're in the first quadrant. We're on the right side of the x-axis where the positives are, and we're on the top half of the y-axis, again, where positives are. So these are both going to be positive. Lastly, we just need to label HOA. H, hypotenuse, at the 2. O, opposite the alpha, also on the vertical side. That leaves A to be on the horizontal side, on the x-axis. Let's set up our ratios. Sine is O over H. That's rad 3 over 2. Cosecant, flip it. 2 over rad 3. And we can't have that, so we're going to multiply rad 3 over rad 3. That gives us 2 rad 3 over just 3. Cosine A over H, 1 over 2, that's a half. And secant we flip to get 2. Tangent, O over A. So that's just rad 3. Rad 3 over 1. Cotangent, flip it. That's 1 over rad 3. Once again, we can't have that, so times rad 3 over rad 3. And we get rad 3 over just 3. And there you have it. Questions over that problem? Knowing you have a quiz coming up over graphing these, you could be asked to graph in radians or degrees or both. Is there one or the other you'd like to see another example of? Will you be ready? That's the question. Okay. So we're going to start our next set of notes.